Okay, so in the last video, I talked about 4 things that you want to look at when you are looking at a new mathematical model. One was the units of the various quantities, any boundary values, the limits of the variables that they get really big or small, and any kind of unusual values. And so let's try apply it to another. Let's imagine another population model, and I'm going to use the following one. P is equal to 1040 over 5.2 minus t. Okay, and again, t is in, let's say, days. Okay, and population is in some kind of number. All right. And we can ask what the sorts of what the constants would have to be. The first thing is we notice a subtraction here, and in any kind of subtraction, the units have to match, and so that 5.2 really should be 5.2 days. Okay, and then for that to then make sense for the units, the 1040 has to give you a number of people times days. So it's kind of an odd little constant. So, but the one here, the 5.2, is really some kind of times, and probably some important time for the process, and we'll see where that ends up coming into play. A couple things. So things that might be interesting. What happens when t is equal to 0? When t is equal to 0, we get the population equals 1040 over 5.2. And notice if I put the units in, and I'm not totally sloppy here, number times days over days, so we're going to get some number of individuals here, which is correct for the units. And this ends up being 200. What happens when, say t is equal to 5? I get, again, p is equal to 1040 over 5.2 minus 5, and this gives me 5,200 in terms of a number of individuals. Notice these are exactly the same numbers as the previous linear model that we discussed at the very beginning. So this equation fits at least those 2 data points. I mean, the initial value of 200 and t equal 5 of 5,200. And it doesn't fit in other places, and one can look. So when you have 2 different models that are consistent with the data that you're looking at, you want to make predictions, and you want to be able to compare it later on. So right now we're just looking at the form of the equation. We've checked out the kind of units and the boundary values. We also can look at some interesting limits. So if I have and there's another boundary value that we'll kind of look at here. What happens when t is equal to 5.2? All right, what we get is the population is equal to 1040 over 0, and it's undefined. If we kind of have it go instead of equal to, but as a limit, then the population goes to infinity. Okay, so essentially at 5.2 days, the population totally explodes. That's the prediction of this particular model. If t is greater than 5.2, that makes it so that the t is greater than the 5.2 in the denominator, and so the population goes negative. And that is clearly ridiculous. So this model clearly breaks down at the 5.2 day mark. And so we could also look kind of back in time. You can imagine what happens if time t is equal to, say, negative infinity. All right. And what that does is actually, so basically going back in time, that actually gives us a perfectly reasonable population equal to 0. And so at least, that kind of approaching zero. So it's very, very tiny. So basically, so it's saying way back in the past there were very, very few individuals in this particular model. So we can kind of look at the limits, some unusual values, obviously, and so on. And then we have a kind of a sense for what these models are actually doing, where they break, what kind of behavior they predict for a long time. Are there any unusual values, and so on? Do they explode? Do they repeat? Do they go to zero? Those are the sorts of questions that one should look at with any particular model. And by kind of following those four things, you'll be able to see that.